In these problems, we're going to be calculating perimeter, which is the sum of the lengths of the sides of a figure. 3 of the sides of this figure follow the grid lines, and we can count the length for each of those. DE is 4 units long, DG is 4 units long, and GF is 6 units long. To find the length of EF, we'll have to either use the distance formula or the Pythagorean theorem. We'll use the Pythagorean theorem, creating a right triangle with leg lengths of 4 and 2, and substitute those into the Pythagorean theorem to solve for the length C. Now that we know the length of the fourth side, we can calculate the perimeter of the figure, adding the lengths of the 4 sides together to find the total distance around the figure. Finding the perimeter of the next figure will be a bit more challenging because none of the sides follow the grid lines. We'll use the Pythagorean theorem to calculate the length of all 4 sides, and then we'll add those lengths together. Use the grid lines to create a right triangle for segment EJ, substituting the lengths of the legs into the Pythagorean theorem to find the length of segment EJ. We'll repeat the same process for segment JB, creating a right triangle with side lengths 2 and 5, and substituting to find the length of segment JB as well. We'll repeat the process again for segment XB, substituting the lengths of the legs into the Pythagorean theorem once again to solve for the length of that segment. And for the fourth side of the figure, segment XE, we'll do the same thing. Now we're ready to calculate the perimeter of the figure by adding all 4 sides together. We're going to calculate the area of this triangle, which is 1/2 times the base times the height. Remember that the base and the height must be perpendicular to one another, and it looks like segment BC and segment AC are perpendicular, but first we need to confirm that they are perpendicular or form a right angle by comparing their slopes. Remember that perpendicular lines have opposite reciprocal slopes. So we'll count the slope for B, which is -3/2, and we'll count the slope for AC, which is +2/3. These slopes are opposite reciprocals, which means that BC is perpendicular to AC, and BC can be the base of our triangle, and AC can be the height. The formula for the area of a triangle is 1/2 base height. We'll need to find the length of the base, segment BC, and the length of the height, segment AC, in order to calculate the area. We'll do this using the Pythagorean theorem, creating a triangle following the grid lines for segment BC and substituting these values into the Pythagorean theorem. And then we'll do the same thing for segment AC to calculate its length as well. Now that we know the length of the base and the height of the triangle, we can use them to calculate the area of the triangle. We'll substitute the length of BC for the base and the length of AC for the height to calculate the area of the triangle, 38.9 square units. Up next, problem solving with circles.